All right, Advanced Math 8, I've got lesson 7.1.1, defining congruence. And we're going to be getting into a little bit of geometry here. So we're going to take a break from algebra. There'll still be some algebra in here, but for the most part, we'll be focusing most of our efforts on geometry at this point. Now, geometry, we need some new terminology to describe what we're doing. The first thing is the idea of congruence. Now, in geometry, we're dealing with shapes. So the term equal is not enough for us. And here's why. Let's say that I've got a square here and another square over here. Okay, let's say that both of those squares are 2 by 2 squares. Now, if we were just using our terminology for algebra, we would say those two squares are equal to each other. But in geometry, we can't really say that, because in geometry, equal means the exact same. These are not the exact same because they take up two different spots in space. They're in two different locations. So we would say that these two are congruent to each other. Congruent means the measurements are the same, but the location is not necessarily the same. When we're talking in geometry, equality means both measurements and the locations are the same. So they're exactly the same. Like, you've got buttons on your shirt. One button is not the same as the other one. They're almost exactly alike, but they're not taking the same spot, right? So the buttons don't take the same spot. They're in two different places. So when they're in two different spots, but the same size and everything, we call that congruence. And we have the equal sign with a little tilde, a little squiggly on top of it. So geometry, when we say equality, we mean it's exactly the same. Not only just the measurements, but it's taking up the same space. Okay, when we say shapes are congruent, the corresponding sides and corresponding angles are congruent. Now, the word corresponding, that just means that they are the parts that match up, and that's what this says down here. Sides or angles from two different shapes that, in air quotes, match up. Okay, so it means they have the same measurements. So corresponding congruent shapes, the corresponding sides and the angles are the same. Now, similar shapes, similar, we use the tilde sign. Similar means that the corresponding sides or the corresponding angles, that instead of being equal to each other, the lengths are not equal, they're proportional to each other. But the angles are still going to be congruent, or the angles are going to have the same measurement. All right, last thing for our terminology is scale factor. A scale factor is the ratio that shows that two things are similar to each other. So we're going to get to that in this first problem here. The scale factor is always found by the length of the copy divided by the length of the original. So what this means is, let's say the copy is bigger. If the copy is bigger, we're going to have a big number over a small number, so it'll be greater than 1. So if the scale factor is greater than 1, it means that it's been enlarged. Now, if I had a small number on top of a big number, that's less than 1. So if we get a scale factor less than 1, that's a reduction. All right, we're going to refer back to these terms as we go. So let's just jump into it. Okay, it says that the polygons below are similar to each other. Remember, similar shapes means that the sides are proportional. The angles are but the angles are congruent to each other. So the one on the left, this one, was reduced, reduction, was reduced to make this one. So this is the copy. This is the original. What is the scale factor? Well, we have to see which sides match up to it. You see how this one's kind of been rotated? Where it looks like this 14 should be matching up with this 35 over here. So let's kind of spin it around in our heads. And this 14 matches up with this number right here. And that would mean if I twist it around, the 10 would match up with the 25. The Y would match up with this 25. The 8 would match up with the Z, and the X would match up with the 7.5. So those would be the corresponding sides. So we want to find the scale factor. So the first thing we're going to do is the length of the copy. So I'm going to find a copy length. I'm going to start with this one right here. So for my scale factor, it's going to be the copy, which is 14, over the original, which is 35, because those are corresponding sides. Now reducing that, 7 goes into both of those. That reduces to 2 over 5. So that's our scale factor. Now this number is less than 1, which means it's a reduction, and they told us it was reduced. So this makes sense. So if you got 5 over 2, it's because you put the original over the copy instead of a copy over the original. Now what this says is that all of the sides are going to match up, and they're going to be proportional, meaning that they're all going to have the same scale factor. So I used this side and this side, but I could have used another 2 sides, because we said that this side here matches up if you spin it with this side here. Let's look at the scale factor of those 2 sides. So copy is 10, original is 25. So if I did 10 over 25, I get the same scale factor of 2/5. That means they're proportional to each other. So everything's matched up. Now we're going to find the lengths of the missing sides. Okay, let's start with the X. The X, remember we had to kind of spin this one in our head, so spin it, should match up, should correspond with this one up here. So the copy is X. It corresponds to 17.5. And now we know that since they are similar, they all have the same scale factor of 2 over 5, which means they're all proportional. That means that X over 17.5 should reduce to 2 over 5, because they're all going to have the scale factor of 2 over 5. And now we can just do cross products to find out what our answer is going to be. 5 times X is 5X. 2 times 17.5 would be 35. Divide by 5, and now we know that X is 7. And 7 over 7.5. So if I do 7 divided by 7.5, oops. If I do 17.5, 7 divided by 17.5, I get 0.4, which is 2/5. So that makes sense. It has the same ratio. All right, let's do it for the other ones. Pink. Where's Y? Okay, Y is over here. So spinning Y around, if you spin it around, it looks like it should match up with this 25 over here. So I'm going to put copy over original, and that should be the ratio of 2 over 5. So doing cross products, I get 5Y equals 50, so Y must be 10. Okay, the last one we got is Z. So looking at Z right here, Z corresponds to 8. Okay, it's copy over original, so I'll put 8 over Z. The variable does not automatically go in the numerator. Sometimes it'll be in the denominator. And this should reduce to 2 over 5. So doing cross products, I would get 2z equals 40, divide by 2, and z would be equal to 20. And now we have found the missing lengths by setting up these proportions. Because all of the sides, since they are similar, should have the same scale factor of 2/5 when comparing the copy to the original. All right, next problem. On this one, it says that the smaller triangle, so the smaller triangle is this triangle right here. So this is our smaller one. All right, there's my small triangle. It says that it's similar to the larger triangle. So the larger triangle is this whole thing right here. All right, so that blue one is similar to this one. So the small triangle and the large triangle should have a scale factor between them that we can use to solve. Now we're going to solve for x using the scale factor. What's the scale factor? It didn't tell us. We kind of need to work that out. So let's see if we have any sides that correspond to each other. Well, here I've got x. That doesn't help me for a scale factor because I need to know what the sides are. So x and m, that's not helpful. Let's do 11.2. So I'm going to do my small triangle. So for my scale factor, I'm going to put the small triangle on top and the large triangle on the bottom. Now this 11.2 is from the small triangle, so I'm going to put that on top. And then it corresponds to this 28 down here. Here's the corresponding parts. So 11/2 is corresponds to 28. Now we could have typed that into our calculator and see what that is. 11.2 divided by 28, which is 0.4. Oh, which is exactly what we had before, 2/5. So it reduces to the same amount that we had in the previous problem. We could leave it like 11.2 over 28 if we wanted to, or we could actually change it. It really doesn't matter. So we've got that it will reduce. Great. What do we do now? Well, we're supposed to solve for x using the scale factor, okay, and then solve for m and p using the Pythagorean theorem. Okay, so x, that's from the small triangle. Okay, x is from the small triangle. Now what corresponds to it? 27 does not correspond to it. Because remember, it has to correspond to an entire side. And the entire side over here is x and 27 together. So it corresponds to x plus 27. So this small side from the blue triangle corresponds to this big side from the pink triangle right there. So small over large is x over x plus 27. So we're just going to set it equal to 11.2 over 28. Because here's our scale factor. And we've got small over large, small over large. Now we could have reduced this fraction if we wanted to. I'm not going to worry about it for right now. We're just going to use our calculators as we do this. So we can do cross products. X times 28 is 28x. 11.2 times x is 11.2x. And then 11.2 times 27, calculator time, is 302.4. Okay, so at this point, I can now say that if I subtract 11.2 from both sides, I get 16.8x equals 302.4, and then divide by 16.8. Oops. 302.4 divided by 16.8. And we get x is equal to 18. So now we know that this is 18. Okay, so it says, then use the Pythagorean theorem to solve for m and p. Okay, Pythagorean theorem. So let's solve for m first. So we'll do 18 squared plus 11.2 squared equals m squared. Okay, so 18 squared plus 11.2 squared equals m squared. Okay, so 18 times 18 is 324. 11.2 squared is 125.44. And that should be equal to m squared using the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to add 324 and 125.44. And we get 449.44. Okay, so at this point, I want m, not m squared. So in order to get m by itself, what we should be doing is taking the square root of both sides. So the square root would be equal to, let's see, square root of 449.44 is 21.2. So we would get m equals 21.2. So now we know that m is 21.2. Okay, so at this point, we need to find out what p is. Now we can, if we want to, use the Pythagorean theorem, but I think I'm going to change how I'm going to do this. Because here's the problem. I'd have to do 28 on this side, and then this entire side over here of 18 and 27, that should end up being 45. So I could do, oh yeah, I guess I could do the Pythagorean theorem. I could do 45 squared plus 28 squared equals all of this squared. Yeah, let's do it like that. That's fine. So we're going to do that. This side's 45, this side's 28. So I'm going to do 45 squared plus 28 squared is equal to c squared. We're just going to call this c. We're going to say that c is equal to 21.2 plus p. So this is the whole side over there. Okay, so 45 squared is 2025. 28 squared is 784. And then add those two together. We get 2809. I think that's a perfect square. And then we're going to take the square root of both sides. Square root of that side, square root of this side. So square root of 2809 is 53. So we know that C is 53. So if I want to find out what P is, then I would say that, let's do a different color here. I would say that 21.2 plus P is equal to 53. And so if I do 53 minus 21.2, I get 31.8. So P is 31.8. So we used the proportion of 11.2 over 28 to solve for x. And then we used the Pythagorean theorem to find for m. And then we used the Pythagorean theorem to find for this whole side. And then we just did 21.2 minus p equals whatever the Pythagorean theorem said over there. All right, that was pretty meaty. That was good stuff. Okay, so that's enough with similar. Let's go into congruence. So which polygons appear to be congruent to each other? Remember, congruent means they have the same measurements, so the angles are the same and the sides are the same, and they're maybe in two different places. So looking around, you might see B and D and think, oh, those two look the same, but I don't think they are. If you look here, this side here, see how these two angles, this is one really big angle, it looks bigger than this one. I bet if we spun this around and put it on top of this one, they wouldn't be quite the same. In fact, I think at one point I cut these out to see if they were the same, and they don't end up being the same. This angle here is not the same as that angle there. So B and D don't look like they're the same. It looks like C and I look like they might be the same, but this doesn't look completely like a 90-degree angle. So it looks like it's a little bit less than 90, and this one they told me is 90 degrees, so those don't look the same. I think F and K, those look like they have the same lengths and the same angles. I think that E and H look like they're the same lengths and the same angles. So we got several of them that look pretty much the same. So I'm going to say E and H. I'm going to say F and K. And I will say, is L and G the same? Yeah, L and G look like they might be the same too. Maybe. Yeah, if we spun them around, maybe L and G are the same too. Okay, so we're just kind of looking at it. So we think that F and K look like the same. E and H look like the same. These almost look the same, except we looked and we saw this angle slightly different from that angle, so that wasn't quite the same. And then B and D, they're close, but we can see that this top angle and this angle right there, it looks like they're supposed to correspond to each other, and it doesn't look like they're quite the same. So we got that. Stupid lights, seriously? All right, so name a sequence of rigid transformations that demonstrates that polygon E is congruent to polygon H. So how can we show through rigid transformations that these two are the same as each other? Well, here's what I would do. I would first start by translating this one so that these points match up. So this point goes to here, and then I'd translate it so that this point goes to here. Remember, translation is just putting your finger on it and sliding it. It looks like if I slide it there, those two would match up. Now, if I did that, they would end up looking like this. So first, I would translate H to the left. And then I'd do it until it touches the side over here on E. Okay, after I translate it, I would probably reflect it. And then this side would reflect onto that side, and then they'd be on top of each other. And that's what would prove that they're the same, because once it's on top of each other, we see that they're the same exact shape. And remember, these are rigid transformations, which means that they keep their shape. So if I translate it back and then reflect it, so I'd reflect over the line that they share. We'd see that they would be the same exact shapes. So I'd translate it by moving it there, and then I'd reflect it by flipping it over, and then they'd be on top of each other, and that would prove that they're congruent to each other. All right, moving on. All right, so we're going to use the Pythagorean Theorem and the Triangle Angle Sum Theorem to prove that the triangles are congruent. Now, the Triangle Angle Sum Theorem, if you haven't heard of this before, this says that the sum of the interior angles of a triangle equals 180 degrees. So the three angles inside of a triangle should always add up to 180 degrees. Remember, the Pythagorean theorem is for sides. That one says that a squared plus b squared equals c squared. And this only works for a right triangle. So we're going to use a squared plus b squared equals c squared for the Pythagorean theorem. And then angle sum theorem just says that the sum of the interior angles of a triangle have to add up to 180 degrees. All right, so far, let's start with the Pythagorean theorem. This one says 16 here and 63 here if these two triangles are congruent to each other. Now, they don't look like they're the same size, but sometimes the sides are, or the triangles are written not to scale, meaning this one's actually bigger, it just wasn't drawn bigger. But in real life, it is bigger because it has this 16 measurement here. Okay, so I'm going to use the triangle, the Pythagorean theorem here to show that this side is going to be equal to this 65 over here, because then I'd have 16, 63, 65, and then this is 16 and 65. This one would have to be 63 over there as well. So let's work that out first. So I'm going to call this C over here. So I'm going to say 16 squared plus 63 squared equals C squared. And I want that C to be 65 to prove that they are congruent to each other. So 16 squared is 256. 63 squared is 3669 or 3969. All right, add those two together. I get 4225. Okay, then to get C by itself, we take the square root of both sides. So we're going to take the square root of 4225, and that comes out to 65. So C is equal to 65. So now I know that this side over here is 65. Now in geometry, what we do is we mark things are the same, sides are the same, by putting these tick marks. So this is the same as that. And now I've proven that this one here is the same as this one. So I'm going to put 2 tick marks on this one and 2 tick marks on there to show that those two are the same. And then we could do the same thing over here, where we would do 16 squared plus b squared equals 65 squared. We already know it's going to be 63, but we'll just do the work here. So we get 256, 56 plus b squared, so I'm solving for this side over here, equals 65 times 65 is 4225. I'll subtract 256 from both sides. I get b squared equals 3969. And then take the square root, and I'd find out that b is equal to 63. So that means that this side has to be 63. And now I can put 3 tick marks because this side is equal to this side. So far, I have proven that all 3 sides are congruent, that they correspond. This side corresponds to that one. This hypotenuse corresponds to that one. And this leg over here corresponds to this one. But in order for triangles to be congruent, the angles also have to be congruent as well. They have to correspond. So the Triangle Sum Theorem says that the 3 angles have to add up to 180 degrees. So we're going to call this one right here x, and we're going to solve for that angle. So we're going to say x plus 90 plus 75.75. Those 3 angles, according to the Triangle Angle Sum Theorem, have to be equal to 180 degrees. So do 90 plus 75.75, and we get x plus 165.75 equals 180. we'll subtract 165, 75 from both sides, and we get x is equal to 14.25. So we think that this angle right here should be 14.25. So what we see now is that this angle corresponds to this angle. So here we put an angle mark. So see, I put one angle mark there, one angle mark. So those go together. And then that means this one's going to have to be 75.75 as well, because they're all going to add up to 180. So I put two angle marks here and two angle marks there. So those both are 75.75. And then both of these angles are 90 degrees. So now we've proved all the angles correspond: 90, 90, 75.75, 75.75, 14.25, 14.25. So all of the angles match up and all the sides match up: 16, 63, 65, 16, 63, 65. So the Pythagorean theorem is used to find that the sides are congruent. Triangle sum theorem is used to find that the angles all match up. All right, and that brings us to our next part, a congruent statement. A congruent statement is something that we write down to prove that two triangles are congruent. And what it does is it places all the parts in order. So that means if I start with an A here, D over here matches up to it. If I put B here, then E matches up to it. If I put C here, then F matches up to it. So let's just draw a real quick thing right here, just to see what we're talking about. So this one's going to be A, B, and C. And then I'm going to draw a triangle that looks just like it right next to it. And this one's going to be D, E, and F. Okay, since we have this congruent statement that says that these two triangles are the congruent, remember congruent means they have the same lengths of their sides and the angles are exactly the same. So since A goes with A, or A goes with D, we can say that angle A is congruent to angle D, because first letter, first letter. So we're doing all the parts, we're stating all the sides and angles that are congruent. So A and D, those two would be congruent to each other. So this angle and this angle are the same. Next in order, B and E. So we can say that angle B is congruent to angle E from the other triangle. Then we've got angle C matches with angle F. All right, now we're going to do the sides that are congruent. The first two letters here are AB, and here we got, this is side AB. So we can say that side AB, and to write side AB, you do AB with a line over it, that it is congruent to side ED over here. So the first two letters go with the first two letters. So this side AB matches with this side ED over here. Then we can say the next two letters are BC. So we can say BC, so this side here, it matches with EF, which are the next two letters here. So it's congruent to side EF. Lastly, the first and last letter are A and C. So AC, that's this side down here. And then the last two letters are D and F over here. And that's this side right here. So we can say that AC is congruent to DF. So once we have two triangles that are proven congruent, we put them in this order, which is called a congruent statement, where all of the corresponding parts are matching up. A goes with D, B goes with E, C goes with F. So there's those congruent ones. And then the sides also match up. AB, DE, BC, EF, AC, DF. So everything matches up when we have a congruent statement. Okay, so this one says that these triangles are going to be congruent. So we're going to put them in order. So I already know they're congruent. So I've got this side that's 20, and this side is 20. So those two sides correspond. You see how they're out of order? But that's fine. This side's 8, and this side is 8. And then this side is 16. We'll put 3 tick marks there. And this side is 16. 3 tick marks there. Okay, now we want to put them in order. Now, when you put them in order, the first triangle does not matter. I'm going to say triangle, let's do MPN. So triangle MPN. So the first triangle you write down does not matter. You can draw it in any order you want to. But the second triangle has to match up with what you wrote for the first triangle. Now, the first letter that I wrote down was M. M is between 1 tick mark and 2 tick marks, right? So because I matched up them. So M should correspond to U, because U is between 1 tick mark and 2 tick marks, and M is between 1 tick mark and 2 tick marks. So those two angles should match up with each other. So I have to do U right here. Next, I wrote P. P is between 2 tick marks and 3 tick marks. Over here, V is between 2 tick marks and 3 tick marks. So V comes next. Lastly, I've got N. N is between 1 and 3. And what do you W are last ones between 1 and 3. Now watch what happened. MP, that's our first two letters. 2 tick marks there. UV, first two letters. There's also 2 tick marks there. So those two are matching up. PN. PN was 3 tick marks. VW. VW, 3 tick marks. That's matching up. First and last are M and N. That's 1 tick mark. First and last are U and W. 1 tick mark. Everything's matching up in our congruent statement. All right, write a series of transformations that proves the angles are congruent. Okay, so if I were to be doing this, I'd say, okay, this angle U has to match up with M. So I would move the triangle from U to M. So I'd move, translate, triangle UVW, so that U is on top of M. Okay, so I'm going to drag this to this spot here. So this triangle now would be kind of sitting in a weird, it'd kind of be looking like that, right? So I've moved this one to here, but it's still going to be facing the same way. So the next thing that I would do is I'd probably rotate it. I'd rotate it like this way so that this point here, we're on top of that one, because W and N go together, because N and W, they're the last two. So I'd rotate it counterclockwise about M. Until W, because this is where W would be, until W is sitting on top of N. Okay, and so once W is on top of N, this MN here and this UW would be on top of each other, and then I just reflect it over MN. And then those two shapes would be on top of each other. So I'd pull this one up here, I'd rotate it So move this up to here, and then I'd flip it, and then the two shapes would be on top of each other. It just kind of takes some doing in your head kind of stuff. Not too bad. All right, so that's all we've got for today. Math hard. We've got our next lesson coming up tomorrow. See you later. Bye-bye.